but doesn't mean that I can do it. Here, let's see this blurb function. So here it's a cycle pen are my pen specification. So I make a shift followed by a cycle pen, which is a cyclic pen shape of a given radius and a given color. And I combine this 20 times with the radius that depends on the time I am combining this. And I'm concatenating everything. So this language is a lot semantic oriented, and there should be the result. This is something that always happens in GPU. The result is not.
Is there any chance you can make the font a little bit?
Yes, sure. I think so. That this no, this could be better.
Oh, great! Thank you.
You're right. So this demo is making a bit of a shift and then a blurb, and this blurb is this thing. So we see nothing. Actually, fortunately, I put a bit of. Okay, this is the blurb. We had some ad hoc arrow moving, or actually even joystick moving on the scene. So, and even a bit of speed so that we can traverse the scene. So let's go a bit this way, and then I can turn and have a look at what is the blurb. Okay, I'm gonna. This is a bit. I need to go a bit far away so that then we can have an idea of what the blurb is. Then I can move and try to see the thing back. Okay, it's there. You see, the color is a bit weird because it's actually there is some photos reflecting on the thing because it's a bit more advanced than this. So this is the result of an extrusion. It's very easily sort of alive or biomorphic because the radius is specified by a sinus. What if I put the time here and actually the time is rational, so I should rather is float, so I should rather do this, and let's try to make it a bit more efficient. So instead of recompiling all the time, there is this very cool thing that should be somewhere there. Okay, I will. There is Ash Alive that allows to recompile on the fly. Main. I need to tell him where are the sources. And okay. Oh yes, you're right. There is an error here. So let's forget that one. Let's put here a blurb of T. I'm just making here an animation. I must confess that our time monoid semantic was nice on the paper, but we are still not convinced that it can give a good programming interface, or a few things are missing. Okay, here is the scene. We see nothing, but we should find it somewhere. It's all black. Oh, it's moving. It's moving. Theoretically, the idea is that we want a program that can be used by non-mathematician. At the moment, it's not that clear because playing with sinus and cosinus is a bit hard. But it's making a bit weird thing because probably. So I'm only drawing one side of the surface. The other side is transparent. and because of this sinus and cosinus, probably it is going inverted, and so it's alive. It's alive. Perhaps it's I'm not my wife generally is telling me that when I'm programming, I'm no longer an handsome man. I'm very weird, and so perhaps I need a bit of programmer costume. It will be better. It's a bit small, but and perhaps with let's add. Actually, let's forget about that program, and I want to show you a complete program that I've already done, which is a bit more fun to go into. And I will compile it. And in the meantime, I can prepare something else for it to be a bit more cool. It's a bit of music, in fact, because I like programming, listening to rock music. Generally, I only listen to classical music and jazz, but when I'm programming, it makes it a bit of music. Yes, and let's try the. Let's make it full screen. And then I can traverse our drawings. There are gears. That's cool. You can visit the gears, and it's nice, isn't it? There's sort of Saturn. There is no collision detection, so it needs to be at random. And somewhere there should be. I'm lost. Oh, I have something better. I have something better. Let's put. So this is the kind of thing I'm drawing. The music is very important, of course. And it's recompiling. This is sort of the full power. Now there on the side there is this, what gives the name to the program, Octopus. It's a bit of extrusion with sinus and cosinus and sort of dance in the space. I can move nearby. The truth is that several days of programming to tune it correctly so that it moves the way I want. With a bit of collision detection, I would expect to surf on that thing. Okay, and I think that's enough. Thank you for your attention.
Time for more questions?
Yes.
So you've mentioned quite often with some holding your nose about the sinus cosine thing.
I hate this.
You hate them, yes.
Yes.
So that's you're being honest about it, and
Yes.
we can
And
tell.
it turned out that to compute normals, instead of using cosinus and sinus on triangles, you can take goes into inverse geometry,
Mm-hmm.
and then it's only a matter of computing cross product and the scalar product, and that's it. And you need not a single I've thought of a theorem that avoid using any
So
consistencies.
do you think you could just get rid of them completely then?
Yes,
That-
yes.
That,
And then-
that's planned.
Yeah, it's probably related. There is a mathematician now in New Zealand or Australia, that a teacher that is claiming that he has a geometry without cosinus and sinus, and it's known in Haskell because the cross product of if you take the known product of the vector by itself, it has a name, and that name came from that mathematician in the library.
Well, I'd be very interested to know about that, but yeah, we can follow up later, so thank you.
But then, actually, I put a lot of sinus and cosinus, not knowing what it meant to move the tentacles of my flowers or octopus, and it's very great magic powder. It animates things a lot and very nicely. Yes.
Maybe you could combine a turtle that describe the 2D object and another one that do the
Yes.
extrusion.
That's true. But
Because in a logo, it's well known that if you want to make a circle, you just move a little bit and turn a little bit. Just
But,
by doing
okay,
that, you
I give you the radius.
Mm.
If you do this, you will have a circle, but what will be the radius? Because the amount you move and turn, it's the cosinus or sinus, I never remember, times the radius you are expecting.
Yeah, but
You
anyway,
need
you are
math.
zooming out and in, so you don't care really.
Well, if your circle is 3 kilometers wide and your string is supposed to be 100 meters square, then yes, it's true. The point is that we sort of quickly sacrifice to efficiency to go on the GPU, which would mean that the little surface that we could extrude would need to be computed on the GPU, which means that GPU is a highly parallel machine, so each process will compute the surface. This will be a waste of time. In terms of efficiency also, distance functions are incredibly efficient to make incredible things. And, but again, how to send distance function that change with time on the GPU, this is not clear. Yes?
How do you actually go on the GPU? What Haskell libraries or programming techniques did you use?
So I can show you the code, the main code, which is the drawing, and let's make it bigger. So this is the octopus. There is somewhere something called the move, and the move is so there are the pen shape, pen type, etc. The move should come here. First, there is the notion of scene. What is a scene? Actually, this is arrays, but C-compatible arrays directly in the memory. And the move is something that acts over this scene. So a move is something that takes a scene, and because it writes down in the memory, it produces an I/O of scene. Because then at the end of accumulating, so I call them moves, but this is rather a mixture of moves and drawings. At the end, I have something in the memory that I can send to the GPU. And what I send to the GPU, so in the GPU you have the notion of vertex. What the vertex I send to the GPU are actually positioned with matrices, and given the pen shape from that position in the geometry shader, I create the curve that will be extruded and the triangle that relate these curves. Yes, and then at the fragment stage, I put the right colors and reflection and whatever.
Will it be specific to one model of GPU or to one?
Sorry, this is OpenGL,
OpenGL.
shader programming with the free stage geometry pipelines. So vertex shader, geometry shader, and theoretically the geometry shader is not used to. It should not be used to create vertices. I can create from 5 to 128 vertices on that version. But nowadays, at least on this small Macintosh Pro, but small, you cannot find a smaller one. It runs pretty well. and manages with load balancing and things like this. Okay.
Okay, thank you again.